Hi everyone, I'm Anirban from Thinkercad Lab, and this is episode 1 of our new series, The Basics of Robotics. So here we will be learning robotics from A to Z. So first, let's start with what is a robot. A robot is a mechanical augmentation of us, the humans. We have always built robot in our own picture, whether it be a mechanical arm or a full humanoid. The robots has been always based off humans. So, if I tell you you have a robot right in your house, will you believe it? Well, look up because the ceiling fan is the simplest example of a robot. In earlier times, we all know that people used to have handheld devices, the traditional the bamboo leaf or palm leaf fans, the coconut leaf fans that we still see today in the market, the things that we used to have that was our only option in the earlier days to cool ourselves. But right now, we have a mechanical device hanging from the roof of our house, spinning and cooling us via electricity. So that's the basic example of robotics. So today we will be building another such basic robot, which is a LED blink pattern like the ones we see in the Diwali festival in all our homes, especially in my country, India. So let's jump in. Today we will be using a web-based software called Tinkercad. Tinkercad is a software made by Autodesk, the same company that makes Fusion 360. So it's a pretty industry standard software, and the best thing is it's web-based, so you don't have to download anything on your computer. So let's fire up Tinkercad. As you can see, I have fired up Tinkercad on my computer, and this is my workspace. Tinkercad offers services like 3D printing, 3D designing, code blocks, and lessons for people who want to learn, and teachings for educators who want to teach. Today we will be using the circuit feature of Tinkercad, which can be used to create and simulate circuits in robotics. So let's jump in. This is our workspace. As you can see, it's totally empty right now because I don't have any projects. So I will just go to create new projects, create a new circuit right here. And as you can see, it's loading up a new circuit. On the left hand top corner, there is a random name that has been given to my project. Let's change it to something more logical, like let's say we will be blinking an LED today. So let's change it to blink example. So I will just type blink example. So yeah, I have written the name here, so I will just click outside and the name will change to blink example. So now that our project has been named, let's go on and add some components. So in the center portion of our screen, the white part we see is called the workspace area. So this is where basically we can place our components and make our circuits and simulate them. On the right hand side, the bar you see with the various components is a component speaker. So right here we have components from basic to advanced, all kinds of components. And so let's jump into the project. For the blink circuit, we need something to blink first, so namely an LED. So I will just select the LED and I will pick it from the component picker and place it in my workspace. As you can see, I have picked the LED. It can be any color. It's red right now, which it is by default, but I can change the color to green, yellow, orange, blue, and even white. So yeah, next I will be picking a brain. Like humans have brains, so robot by logic but also must have a brain. So I will give a brain to my robot, which in this case is a microcontroller called an Arduino. So I will just pick and place an Arduino in my workspace. Now the Arduino by default supplies a voltage of 5 volts, which is enough for our LED, but it also supplies a current of 40 milliamps through its digital pins, which is more than our LED could take. And if I connect it directly, it would most likely would burn. So to safeguard the LED, I will be adding a resistor, which will be used in here as a current limiting resistor. So let's add a resistor. I have picked the resistor and I have placed it in my workspace. And as you can see, the resistance has a value. It's 1 kilo ohm. But I don't need a value this big. For this project, we need a value of 220 ohms. So I will change it to 220, and then I will change it to ohms. So as you can see, our resistance is now ready and the circuit is ready to be connected. So I will just connect one end of the LED to to the Arduino pin via the resistor. So I will just connect this to say pin number 2. Next, I will connect the LED to the resistance like so. And next I will connect the cathode of the LED to the ground pin of the Arduino like so. Now to avoid confusion, let's colorize the wires. The wires are green by default, but I will color them with the standard convention, which is red for the positive and black for the negative. As you can see, our setup is totally ready and we can start our simulation right now. But can we now? No, we can't, because we haven't coded the thing yet. So let's dive into the coding section and code our robot. So I will just open up the coding section. As you can see, the code is done here via blocks, which is pretty easy. You don't have to be a programmer, you don't have to write the code by your own, by text or whatever. So I will just, there is a pre-existing bit of code which I will just delete like so. And now I will just put some new code in place. So we want to blink the LED say once per second. So the LED will turn on, wait for 1 second, then turn off, then wait for another second before turning on, and the cycle will continue. So let's search in the pins. So first we need to turn on the LED. So I will select this block, set pin 2, and since we have connected our LED to the pin number 2, as you can see right here, I will set this one to pin number 2 as well. So there it is. And since we need to turn the LED on, I will set it to high. So on means high and off means low. So now we need a delay of around 1 second. So let's do that. So here it is, the wait, and here you can edit the number of seconds and you can also change to milliseconds if you want to do things which are like faster than a second. Next, I will place another block to turn the LED off like so. Again, let's not forget to select the correct pin, which is pin number 2, and set it to just low. Next, we will be adding another delay block of a second. That's it, guys. Our circuit is complete. Now I will just close the code tab like so, and close the part speaker tab, which is no longer required, like so. Okay, guys. So our circuit is totally complete, and once I press start simulation, you guys will see the LED blink once per second. So let's start the simulation. As you guys can see, the LED is now blinking. I'm going to zoom in on the LED for a better view, like this. So as you guys can see, the LED is now blinking once per second. And now, if you are like building bigger projects, so due to the load on the server and other network stuff, the speed of the real world clock might not be equal to the simulation speed. So how to know if our simulation is going according to time? Let's check this thing. It's called the simulation time. It's on the top of the simulation always, and the simulation is sequenced to that time. So even if the simulation slows down, that clock will slow down as well. So as we can see on the clock, with each passing second, the LED is turning off, waiting for a second, and turning on. So hereby it's proof that our simulation is working quite correctly and our robot has been formed. So we have successfully created a robot just out of an LED. Thank you guys for watching, and if you liked our content, please place a like below, and we do love feedbacks, so please don't forget to comment and share how you liked or disliked the video. Comment in either way, and if you want to know more about this, please visit our website thinkinginlab.com. We are always there to help you and teach you and guide you. And if you do like to continue watching more content like this, please consider subscribing to our channel. Thank you.